Well, welcome everyone. I'm JJ. Let's go ahead and just jump in and tackle an example problem. So this time we have a 520 Newton force that we're working with. We're going to try to get it expressed out as a Cartesian vector, so we need to get those I, J, K components or the X, Y, Z pieces. Then we'll try to figure out a unit vector that goes with the same direction of it. And finally, we'll get our alpha, beta, gamma angles, those coordinate direction angles figured out. On this one, we aren't really given them. We're given what's our theta xy angle? What is the angle from 3 dimensions? So if my arm is like the table or the horizontal plane, we have some angle, some force up in 3 dimensions. And I'm given an angle down from the force to horizontal. Theta xy is 75 degrees. Once we have that horizontal piece, I can figure out, just moving in 2 dimensions, from my arm to the x-axis is a 40-degree angle. So we're going to have to figure out how to get to x, y, z pieces in here. We should be able to do that. So first off, let's come in and say, I know that from my z-axis to the xy plane is 90 degrees. So let's start there. 90 should get us, our gamma goes from z to the force. So gamma plus theta xy goes from the force to the 2-dimensional plane. So gamma plus 75 degrees is going to get us gamma figured out. We can solve that for gamma. Just moving the 75 over 90 minus 75 is going to get us the gamma is 15 degrees. Which this is actually one of our answers. It's the very last thing. What is gamma in here? We were able to start out and find that at the very, very beginning of this. We'll check our answer as we work through the entire problem on here to make sure that worked out to be correct. I'm going to move that down just so it's not off the top of the screen. Gamma is 15 degrees is our answer. But with that known, we can then come in and start getting everything else figured out. So let's get Fz first for this. My total force in the z direction, Fz, should be my total force, 520, times the cosine of gamma, just like it is when we were given alpha, beta, gamma angles. Cosine 15. Or this is going to get me that my Fz is 502 newtons. From there, I can start working with, rather than a 3-dimensional force, let's get this Fxy, a component of this 3D force that only goes in the x and y directions. We're kind of eliminating the z component out from that. So I can get Fxy by saying this is my total force times the cosine of theta xy. Again, this will always work for us. So theta xy is 75. My total force is 520. So this is 520 cosine 75. Or my Fxy works out to be 134.6 newtons. Our next piece, we can come in and say, if I have that 2-dimensional piece, really it's just breaking things up into x and y components. I have a 2-dimensional triangle in here with a y component, an x component, and a hypotenuse on that. My hypotenuse, Fxy, is 134.6. My x-axis would be adjacent to that. So I can say that my Fx is my hypotenuse, Fxy, times the cosine of theta. Cosine theta. Or this is going to get us Fx is Fxy, 134.6, times the cosine, because it's adjacent to Fxy, cosine of 40. So Fx works out to be 103.1 newtons. 103.1 newtons. Finally, I can get Fy as well. Fy should get me, I have a 2-dimensional triangle here, Fxy, Fx, Fy. So my total force in the xy plane, Fxy, and that y component here, y is opposite my angle. So I need to use sine. Sine theta. Or this is my fxy, still 134.6, times the sine of theta, which we're given as 40 degrees. Sine 40. Or this is going to get me to 86.5 newtons. Which right now I have x, y, and z components. That's what I need. I can make that into an I, J, and K direction to get my first part figured out. F as a Cartesian vector should get me to, we'll have my force as a vector is, I'm going to pull the newtons out, but I need Fx, 103.1. 103.1 I plus Fy plus 86.5 J plus Fz plus 502 K newtons, which would be my first answer for our problem. From there, we were asked to come in and say, let's get a unit vector that points in that same direction. This time, rather than doing our inverse cosine approach, I don't know alpha, beta, gamma yet. I could also write this, though, as my unit vector that points in the direction of F should be my force vector divided by the magnitude of my force vector. I have that force vector. I know the magnitude. I was given that. It's 520. Really, I can lay this out. This is, we'll split it up into I, J, K pieces as we go, but 103.1 I, that's my Fx, divided by my total force, 520 over 520. Plus, we'll get our y component, 86.5 J divided by my total force, 520. Still. And then finally, let's do that for our K piece as well. Plus 502 K divided by my total force is still 520. But doing that, 103.1 over 520, I'm getting here my unit vector in that direction of F. 103.1 over 520 is 0.198 I. 86.5 over 520 will get me plus 0.166 J. And 502 over 520 will get me plus 0.965 K. Which will get me my second answer. What is my unit vector? I got an A and B. Finally, I just want to come in and get my coordinate direction angles. We could also work through this. A unit vector is the cosine of alpha in the I direction, plus the cosine of beta in the J, cosine gamma in our K. Really, if I have this as the cosine of alpha is 0.198, I can take the inverse cosine of that to get to alpha. So I know cosine of alpha. Cosine alpha is 0.198. The I component of my unit vector. Solving for alpha, taking the inverse cosine of 0.198, I'll get that it is 78.6 degrees. And then just repeat that for the next two. Cosine of beta should get me to 0.166. Solving for beta, the inverse cosine of 0.166 is going to get me that this is 80.4 degrees. And finally, my last one, the inverse cosine, or the cosine of 0, or cosine of gamma equals 0.965. Taking the inverse cosine of 0.965, we'll get that gamma is 15.1 degrees. Technically, we could have skipped over that. The one reason we're throwing that in here is to compare. We got this at the very beginning. We said it was 15 degrees. Here I got that it was 15.1. A 0.1 degree difference in this is just a rounding difference as we went through all of our work. Rounding differences really aren't a significant thing in engineering unless you're doing something weird with your rounding. Don't stress out about it in general. Your professor might say something different, but we will build safety factors into like any engineering design and make it that 0.1 degree probably is insignificant. But if this was useful for you, go ahead and like and subscribe. Let's help you get an A with JJ.